Hello and welcome to this coding lecture. In this coding lecture we are going to work with the model class, because so far we have created our model directly from scratch, but now I'm going to show you how you can set up your model in a separate class, which you then can easily instantiate and use in the further code. Alright, for this I have opened the linear regression model class start script, which is just providing some code for loading the required packages, and I run this first chunk. Then it's also having the data import ready to start, and you're going to see this is the same dataset that we have used in the lectures before. And then we are converting these lists and numpy arrays to tensors. Okay, everything ready. Now we can create our model class. So for this, we have to type class and we have to give a name to this class. So let's say we want to call it linear regression torch class. And then this one has to inherit from the PyTorch submodule nn.module. So this is the general structure. You have to create this class. The class is inheriting from nn.module, and now we have to specify the init function, which is called when an object is instantiated from this class. So we can create this init function. It needs to have the keyword self, which is referring to the objects inside the class. And then we can specify two parameters. I will call them input size and output size. And then in here, when the class is initialized, we are creating an internal object, which is called linear. And this one is a linear layer coming from the nn module. And this linear class is requiring two parameters. One is for the in features and one is for the out features. So in here we are passing the size of the model. So we are telling that there is one node going in and one node going out. And then every model class needs to have a forward function, which is provided with one variable. Typically that's called x. And since our model is so simple, we can just follow this proposal here. We are just calling the linear layer that we have created before and storing the result in an object called out, and we are returning this one. Later on, when we have more complex models, we will set up more layers in the init function, and then we stack them together in the forward function. Right, and that's already it. So this is our model class. Now we can specify some parameters. Our input dimension is 1, our output dimension is 1, and we are ready to instantiate an object of this class. So here we just create a new object called model, which is instantiated from this class with the parameters we have just specified. And we can run that, and our model class is ready. Perfect. Now the next one is to specify a loss function. And since we're working with linear regression, the loss type of mean squared error seems to be quite appropriate. So we will use this specific function and assign it to the object called lossFun. Then we need to specify the optimizer. In here we can also specify another parameter called LR for learning rate. And let's specify a value for it. And then we need to specify the optimizer. So the optimizer is created from the submodule optim, and then we are going to use stochastic gradient descent. And when this function is called, it is requiring some parameters. So here we are passing the model parameters, which we can extract with model.parameters. And we also can specify the learning rate. And with this we are ready to create our training loop. So this time we are also going to save the losses and the slope and the bias in individual variables. And these ones are lists, which are completely empty at the beginning. And we also set one parameter, the number of epochs, to 1000. And now we can create a loop for it. So we are iterating over 1000 epochs. And here we are now starting. So we are at first setting the gradients to 0. And we are doing this by calling optimizer.zeroGrad. Then we have the forward pass. So we are passing our observations through the model that we have created to get the predictions. And this is exactly the line we want to run for this. So we're passing X, our data that we have set up here, to the model, and we get as a return ypred. Now we have predictions and we also have the true values. So we are at the point that we can calculate the loss. So for this we can call our loss function, pass in the predictions and the true values, and we will get back the losses, which we store in the object called loss. And now we can update the weights by calling optimizer.step. So that would be it if we wouldn't want to learn more of the model. But right here we want to see a bit more into the insight on what is happening. So we will get the parameters and I will show you how we will get them. And then we are going to store them to the losses and to the slope and bias parameters. So we can iterate through the parameters. So in model.named parameters, are all the parameters stored, and we will get back the name and the parameter, and we are only going to check the parameters that are having a gradient required, and then only in the case that the name is linear.weight. So here we are now going to append our slope, and we are going to use param.data.numpy, and we're going to use the very first object. Okay, and we are doing something very similar for the bias term. So in here we are going to append the current bias value of the current epoch. So then we are going to store the losses. Very similar, we are taking our losses object and we are appending what is stored in loss.data as a float. And now we can print the loss. For every 100th epoch, we are going to print the epoch and the losses. All right, let's run that. And you can see here it's not working. The losses are not decreasing, they are constant. Actually, there is a bug in my code, and I found out that I have missed one small line. One very important one, the one in which the gradients are calculated. So we spoke before about the automatic gradient calculation, which is triggered by calling loss.backward. So this one was missing, small line, big impact. So this is very important to calculate the gradients. Good. Let's just clear up everything and run everything again. Just to see. Now this is the expected result. So here you can see we have losses which are decreasing with the number of epoch, and at some point they're getting quite stable. This is good. So now we can, for example, visualize the model training by creating a scatter plot in which we are passing in the number of epoch on the x-axis, and then we are going to plot the losses. So this is the whole purpose why we have stored this object. And here you can see this is a typical representation on how the losses develop. So you start with very high losses at the beginning, and then the gradient descent is in action. You can see that you're getting closer and closer to a good result. And at some point, the returns are diminishing more and more. And at some point, you get a very flat line at the end. At which point, it's not really worth having more calculations. So at that point, you could basically stop the training and work with this final model. We can also do that for the bias terms. So we can, in a very similar fashion, create a scatter plot on which we have a range of the 1000 epochs, and then we are going to plot the bias term. Here you can see the same. We are starting with a very poor result. We are starting basically at around 0, and then we are getting better and better, and we are getting at some point to the statistical result of 36 point whatever. So we can also do the same for the slopes. Same story, we are starting out with some poor results and then a very steady trend towards a constant value at some point. Here it's looking like there's still some significant slope, so we could even think about having more epochs looking at that graph. Okay, so we now can also create our predictions again by calling our model object. And in here we are going to access the data and convert them to NumPy. And we need to remove one dimension to make it work in the end with the plot we are going to create. And then we can create our scatter plot with our x values, which are stored in this list, and our y list. So these are the true values. And now we can put on top the predictions, and we want to be able to differentiate them. So we specify a color. And here you can see it. Actually, it's better if we take a line plot in this regard. Here we are. So we have our observations, the blue dots, and this is our final regression line. So this looks already quite good. All right. So you have learned how to set up the model class and how to create the training for this specific model.